All right, we're on to lesson 2, and now we're going to throw in the octet rule, and we're going to look at the different types of bonds. We have single, double, and triple bonds. All right, so we know that they're going to share electrons. So the octet rule comes from the number 8. What's special about 8? We know if we look here on our periodic table, our noble gases, those are stable, right? We learned from ionic bonds, they transfer electrons, like metals want to give up electrons, nonmetals want to gain. In covalent bonds, they want to share. All right, so let's look at chlorine. Chlorine is in group 7, so it's got 7 valence electrons. So let's grab a different color here. 1, 2, 7. So to form a single bond, we share an electron from each of these atoms. So just draw a line which should be straight. That's ugly. Let me fix that. All right, let's try it again. Go back to my pen. All right, here we go. See if I can draw a straight line. Ish. Close enough, right? So now let's count them up. 1, 2, 3, 4, 5, 6, 7. We count the bond as 2, right? So then we get our 8. 1, 2, 3, 4, 5, 6, 7, 8. So we have 8 electrons for each of those atoms. So that's the octet rule. So we also have double bonds. So let's look at oxygen. How many electrons does oxygen have? It's in group 6, so it has 6 valence electrons. So I'm going to draw 1, 2, 3, 4, 5, and 6. 1, 2, 3, 4, 5, and 6. So if I form a single bond, let's put these two guys together. 1, 2, 3, 4, 5, 6, 7. That's no good. We want 8. So let's form a double bond. Let's share these 2 electrons. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. So by sharing 2 electrons this time, forming a double bond, we've made it stable. So that's where we get O2 and Cl2. Now it looks like carbon and oxygen, so it's carbon monoxide. Okay, so carbon has how many valence electrons? 4. Oxygen has how many valence electrons? 6. Okay, so let's see how this is going to go. So if I have 1, 2, 3, 4, 5, 6, let's say I have 1, 2, 3, 4. So how am I going to handle this? I need to pick up 4 more electrons. All right, so how am I going to do that? That's a good question. Erase these real quick. So if I want to pick up 4 electrons, I'm going to need more than a double bond, right? So what am I going to do? Remember, these guys can share electrons. Think back to the hybridization, how those electrons can move around, right? So let's say okay. So I just erased them. So now I'm going to take, I have 3 electrons that I got rid of from here. I'm going to draw 3 lines. Okay. So how does that work? I've got 1, 2, 3, 4, 5, 6, 7, 8. And then I have 1, 2, 3, 4, 5, 6, 7. What if? All right. So how many total electrons did I start off with? I started off with 6 and 4. So I need to account for 10 electrons. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So I have a lone pair on carbon and a lone pair on oxygen, and then I have this triple bond. Okay? So that is how you can do that because they can share those electrons. All right, so 2 electrons from the carbon came over to give the double bond, and then 2 pairs over here came over to help form this triple bond. Okay, so we have 3 bonds, 10 total electrons. It's a little tricky. Let's look at another example. Let's look at nitrogen. Nitrogen has how many valence electrons? 5, because it's in that 5th column, right? So if it's going to have 5, how many do I need to account for? I need to account for 10 electrons, and I want each of these atoms to have 8. So I form triple bond that gives me 6, and then I have these lone pairs, right? Similar to what I did with carbon monoxide. So the only thing to remember is hydrogen, for example, is not going to form an octet because it just has the 1. So it's going to be like helium, and it's going to be 2. So let's take a look at ammonia, right? Ammonia, so you have nitrogen, which has 5 valence electrons. It wants 8. So if I have 3 hydrogen atoms, right? Each hydrogen atom has 1. 1, 2, 3, 4, 5, 6, 7, 8. So nitrogen's happy and hydrogen's happy because each has 2. Right? That gives us ammonia, which is NH3. So that's the octet rule. Figuring out how to arrange your electrons and the bonds so that you can't create more electrons than you have, and that each has 8. And it takes some reasoning and some practice, but you'll get there. And we'll have some more practice later on, but hopefully that seemed pretty straightforward. Okay, so that was it for lesson 2. I know that triple bonds are a little tricky, so I would suggest that you guys practice a little bit and see if you can figure out a couple. Let's see here. Actually, you know what? Take a look at, let's start looking at a little something different. This is what I want you to practice instead of more triple and double bonds. And we'll pick this up at the beginning of the next lesson. Okay, so I would like you guys to take a look at, oops, figures. There we go. All right, so I want you guys to take oxygen, take a look at hydrogen, chlorine. We'll actually practice this right now, and oxygen. And on a piece of paper, try and figure out what the structure is going to look like. That's 3 atoms instead of just 2. That's a little trickier. So pause the video, See if you can figure that out. Okay, so let's look at this in terms of how many electrons each of these atoms need. Hydrogen needs how many electrons? Oops. 1, right? Because it wants to get 2. How many does chlorine need? 1, right? And how many does oxygen need? 2. So oxygen needs more electrons than hydrogen and chlorine. So we're going to put oxygen in the middle, okay? So let's look at our atoms here. So hopefully you know that oxygen has 6 valence electrons. We know that chlorine has 7 valence electrons. And hydrogen has 1. Okay, so we share an electron. That should be a straight line. And we share an electron here. Okay. So how does that go? I'll just make it a little neater over here. Right? So by looking at how many electrons each atom needs, that helps me figure out how to place the oxygen in the middle because it needs the most. So hydrogen has 1, 2. Oxygen has 1, 2, 3, 4, 5, 6, 7, 8. Remember the bond is shared, so it counts as 2. Chlorine has 1, 2, 3, 4, 5, 6, 7, 8. All right. So that's how we would figure this out. So this is just an introduction. There's a lot more to drawing Lewis dots or drawing these dot structures, but now we're looking at molecules, so that's pretty cool. All right, so take a look at that, review it, fill in your definitions, look in the question in the study guide. What is the relationship between the number of valence electrons an atom shares in covalent bonds and the number of valence electrons an atom has? Okay, write down any additional questions you have and see if you can fill in those statements. All right, good job, guys.